this is I. And so the square root of negative 25 can turn out to be plus or minus 5I.
How would you write it in the word when you had it for equating to the word?
How would you write it in the web sign box?
Plus or minus I instead of 15?
Oh, yes.
Okay.
We'll get to that in just a second. Yeah. All right, so notice the division here, the factoring. Square root of negative 16, you can think of, all right, that's square root of negative 1 times square root of 16. That's just 4, and that's defined to be I, so we'd say plus or minus 4I. So far, so good? Well, what if it doesn't come out even? What if I got square root of negative 15? Well, it's still the same thing. Square root of negative 1 times square root of 15. But does square root of 15 simplify? It doesn't, so it simply stays square root of 15I, or I square root of 15. Was anybody instructed in your more formative years to put the I before the radical instead of after? Okay. I think web assign will allow us to do either, but here's why. If I got square root of 3I, if I try to write square root of 3I and I let the I kind of slip underneath the radical like that, it's kind of confusing. So the question is the I underneath the radical or is it not? I can't really tell. That's why it's often encouraged to write the I before the radical expression. No question there where the I is. Yes, ma'am? Further than that? But bottom line for me, I don't care if you put the I after or in front of the radical. It doesn't bother me either. Okay? All right. So as soon as we introduce this concept of I, we realize we're talking about something that my calculator does not know about. We're talking about another kind of number. We're going to call those numbers complex numbers. Now, I think that's a really poor choice of a name for these numbers because they're not that complex at all. Maybe we should call them really easy numbers. Is that instead of complex? But whatever we call them, they're going to be pretty easy to deal with. First thing we want to do is look at a complex number in standard form. And a complex number in standard form is basically going to look like this. A plus B times I, where A and B are real numbers. A and B are elements of the set of real numbers. So notice you got an A, which is a purely real number part. And then you got the BI, which is a number of I values, called the imaginary part. So this is the real number part. And this is what's called the imaginary part. The I part. And here's an example. There's a very typical complex number in standard form. Hey, if it is a complex number in standard form, that means you should be able to identify what A and B are. What's A?
4.
And B is?
3i.
Be careful. What's B?
3.
3. The B is just the coefficient of I. Okay, try this one. That's a complex number in standard form. You should be able to identify A and B. They are? 2 and? Okay. Is that a complex number in standard form? If it is, you should be able to tell me what A and B are.
B is 1.
What's A? 0 and B is? So you're saying that 7i is the same as 0 plus 7i. Is 0 a real number?
Yes.
Does it show up on your calculator?
Yes.
It's a real number. That's a synonymous way to ask the question. You know, is this a real number? Does it ever show up on your calculator? It does, so it's a real number. So hey, yeah. So check it out. Just if you have 7i or 4i or negative 3i, that's a complex number in standard form. It just happens that the A is 0. Yes, ma'am?
Can you add the 4 and 3 together?
No.
Or no, because the I is...
Because it's not really a 3, it's 3 i's. So we won't be combining these real number and the I parts. We will be combining parts, but not those parts. Hey, check this guy out. Is that a complex number in standard form? If it is, you can tell me what A and B are. Anybody got a notion? What would A be? What would A be? What's that? 5. Anybody got a suggestion for B?
0.
So 5 is the same as 5 plus 0i, which would mean B is, in fact,
0.
But check out the implications here, ladies and gentlemen. That means that every single real number is also a complex number. Every single real number is also a complex number because it can be expressed as that real number plus 0i, right? And 0 is a perfectly legitimate real number. So, this is not what I have. Don't write this down because it's wrong. I'm not adding a new set called complex numbers to an already existing set, real numbers. What I'm doing is realizing that the complex numbers contain the real numbers as a subset. Why? Because every real number is a complex number. Okay? So the real numbers are just now a subset of the complex numbers. There's lots of numbers that are complex that aren't real, like your purely imaginary types, or your two-part types that have an imaginary aspect to them. There's a ton of complex numbers that aren't real, but every real number is also complex. How about that? Well, one of the things we've always done when we introduce something new like radicals was we said, okay, let's start doing the operations with these guys. Adding, subtracting, multiplying, and dividing. And that's exactly what we're going to do with complex numbers. We're going to realize that they combine. I can add them or subtract them. And it's going to work so simple. Watch this. There's a couple of complex numbers in standard form. And obviously I'm being asked to add those two. Here's your strategy, and you might even want to jot this down. Treat the i's as if they were a variable.